Today we're going to talk about forcing continuity, which is something that we are able to do in certain situations when we have an unknown constant and we can find the value that will make a piecewise function continuous. Before we look at an example, I wanted to review the formal definition of continuity. So in order for a function to be continuous, three things must hold true at the c value. Number one, the limit of the function as x approaches c must exist, which means that from both sides, it should be approaching the same y value at that particular x value. Secondly, the function value must exist at that particular x value. And last, the function value and the limit value must be the same thing, meaning that the two branches of the function are coming towards the same point, and that y value fills that point or that hole in that particular place. Here's an example where we will determine the k value, which will force continuity of this piecewise function. Once we find the k value, we will also find the ordered pair where the two branches of the piecewise function meet. Now notice we have a piecewise function, one piece defined by kx squared, and that is when x is less than or equal to -1. The other piece being defined by 2kx plus 1 when x is greater than -1. So in order to find the k value, first of all, we need to be aware of the x value in question. And so we are looking at when x is equal to -1, because these are both nice, well-behaved functions. We've got a quadratic and a linear function, which will have no holes, gaps, or asymptotes anywhere else besides this particular x value in question. So we start by setting the two functions equal to each other. Now, once we have the two functions equal to each other, we will substitute in the x value, which is -1, being very careful with parentheses here when I'm squaring. My next step will be to simplify algebraically. -1 squared is +1, so I'll have 1k, which I could also write as just a k. I have 2k times -1, which will be -2k plus 1. At this point, I've got a one variable equation that I can solve. So I'll add 2k to both sides. 3k is equal to 1. And then dividing both sides by 3, I get k is equal to 1/3. So this is the k value that will guarantee that my function is continuous. Now that I know the k value, I want to find the ordered pair where the two branches meet. I already know the x value of the ordered pair because that's what I'm told when I begin the problem, that the point where I'm trying to get them to meet is at -1. To find the y value that corresponds to that, I'm going to evaluate both branches of the function at -1 using a k value of 1/3. So the first branch of the function will be 1/3 times -1 squared, which will give me +1/3. I'm doing the second branch of the function because I'm just double checking my work. This way I should get the exact same value. So I have 2 times 1/3 times -1 plus 1. That gives me -2/3 plus +1, which is again 1/3. What this tells me is they meet at the point -1, 1/3. Now, I want to be very clear on this, that these two values right here are not always the same. This is just coincidental of this particular problem.